Welcome to today's presentation titled Understanding Airworthiness. This is presented to airframe and power plant technicians, repairmen, and pilots. I am Gary Mitchum, the Airworthiness Fast Team Program Manager for San Antonio, Texas. Allow myself to do a brief introduction. I was in the Air Force from 1985 to 93. I was an F-15 avionics technician. Then I was an air training command instructor. I attained the rank of technical sergeant. There's one of the aircraft I used to work on. From 93 to 95, I taught at the Community College of Beaver County near Pittsburgh, Pennsylvania. I was the assistant professor of avionics technology, and I also taught digital electronics. From 95 to 2010, I worked at Dunkirk Avionics in Western New York as a technician and manager. There's some pictures of me at work. Here's a project I did, a Cessna 421C total panel restoration and avionics installation. New panel, silk screened and powder coated, new glare shield, and new avionics. Here's another project, Cessna 172. Same thing, total panel restoration, fabricate new panels, install new avionics, new glare shield. And I came on board with the FAA in 2010. From 2010 to 2013, I was the partial program manager, inspector for avionics over NetJets. And then I got moved back home here to near Buffalo at the Rochester, New York office, where I was the principal avionics inspector for FlexJet from 2013 to 2021. And in 2021, I was hired as the Fast Team Program Manager at San Antonio. My hobbies are I like to fish. There's my boat. There's a nice king salmon on the Genesee River in New York. There's one out on Lake Ontario from the boat. I also do country music, singer and songwriter. And I do subject myself to misery up in a tree at times in freezing weather, hunting deer. And there's my wife and I when we went down to check out our property that we purchased in Texas. So we'll be moving down there finally after our house has just been completed. So let's get started. As aviation maintenance technicians, we restore airworthiness when we repair defects. We continue airworthiness when we service aircraft, and we certify airworthiness when we inspect. AMTs must follow the rules for maintenance and inspection and must understand airworthiness. So today we're going to discuss airworthiness, where to find resources, the definition of airworthiness, 2 elements of airworthiness, real-life examples of airworthiness issues, some factors influencing airworthiness, life cycle of an aircraft, and the performance rules for technicians. Our overall objective today is to reduce the accident rate. We're going to try to do that by increasing our knowledge of what defines airworthiness, better understanding how changes affect airworthiness, identifying unairworthy conditions, determining if an item is in condition for safe operation, and understanding the factors that affect airworthiness. And last, by knowing the performance rules. It's good to know what resources are available to you as an AMT. If you go to FAA.gov and under the Pilot and Airman tab, if you click on the Mechanics tab, There's a lot of resources under that tab. Make it larger. You can see advisory circulars, airworthiness directives, type certificate data sheets, and the forms are there. Handbooks and manuals have their own landing page as well, and they can be accessed from the regulations tab at the top. When you select the aviation link, it'll take you to handbooks of interest. Click on the aircraft tab and you can find some very good aviation maintenance technician handbooks. You can also find the Plane Sense magazine, and I highly recommend that you download those handbooks onto your computer. They're very large. There's a number of volumes for general and airframe and power plant. It's a very good resource. So, two conditions must be met for an aircraft to be considered airworthy. The aircraft must conform to its type design, and the aircraft must be in a condition for safe operation. We're going to look at both of these elements. To understand type design, we need to know what the airworthiness standards are. The type design must meet the criteria and specifications listed in the airworthiness standards the aircraft is manufactured under. This is sometimes called the certification basis. CAR Part 3, Part 23, and 27 are examples of the regulations that are the certification basis. The design specifications for stability, performance, structures, materials, fire protection, power plant equipment, safety equipment, weight and balance, so on and so forth, are all defined in the airworthiness standards. Here we have a chart that shows what we are discussing. The process starts with the airworthiness standards that are developed so safe aircraft can be constructed. This is the certification basis. The manufacturer builds the aircraft according to their type design. They must demonstrate or prove that it meets the airworthiness standards to the FAA. Once all the criteria are met, the aircraft is issued an airworthiness certificate and the manufacturer is issued a production certificate. Notice that the chart also indicates properly altered condition as influencing the type design. If it's so critical to airworthiness, we need to know what type design is. It's defined in Part 21.31a, and this is not the complete regulation, but this gives you an idea. It is the drawings and specifications that show product conforms to its certification basis. The dimensions, materials, and processes to define structural strength of the product, and the airworthiness limitations section of the instructions for continued airworthiness, or ICAs. How do you know if an aircraft conforms to its type design? A good place to start is with the type certificate data sheet. It is a summary of the type design. Now here is an example of a type certificate data sheet for the Cessna 150 series, and it's about 19 pages long. The data plate on an aircraft will show the type certificate number. And here it's 3A21, and this is for a Cessna T210N. Aircraft are type certificated under different parts. For example, small aircraft under Part 23, transport aircraft under Part 25, and so on and so forth. The certification basis will be stated on the type certificate data sheet. Here we see the Cessna 150 certification basis is the old car part 3. The certification basis defines the type design. Here's a snip from the type certificate data sheet for a Bell 407 and 206 helicopter. The certification basis is part 27, and this is not the complete list of the certification basis. It does continue on. The type certificate data sheet prescribes conditions and limitations under which the product meets the airworthiness requirements of the federal aviation regulations. It's important to note that if these conditions are not met or the limits are exceeded, the aircraft will not meet the airworthiness requirements. Here we see the type certificate data sheet for the Cessna 150 lists what engine must be installed, what fuel must be used, and what propellers can be installed. For example, suppose this particular Cessna 150 has a 70-inch Macaulay propeller installed. Does this meet the type design? Is this airplane still airworthy? The answer to both of these questions is no. What if automotive fuel or alcohol-based fuel is used? Will the airplane still meet its type design? No. In both these cases, the aircraft would be unairworthy unless it was properly altered with a supplemental type certificate approving these changes. Here's the section on weight and balance. An equipment list and weight and balance document is always provided at the time of delivery. As changes are made, items are added or removed, the weight and balance and equipment list must be updated. Does deviation from the weight and balance specifications affect the airworthiness of the aircraft? Yes, because the airplane can only meet its design criteria if it is within these weight and balance limits. So here we see the CG is too far forward and there is insufficient elevator travel design to keep the nose up. Overweight or out of CG aircraft are dangerous and do not meet type design. And this aircraft will likely crash. It's imperative that mechanics and repairmen ensure the weight and balance record is updated after maintenance actions. Let's take a look as a review of weight and balance changes. Notice on this airplane, the datum line is at the wing leading edge. An arm is a measure of distance in inches from the datum line. Positive arms are aft of the datum, and negative arms are forward of the datum line. We see the center of gravity on this airplane is about mid-wing. Maximum weight is the maximum authorized weight of the aircraft and its contents. This will be indicated on the type certificate data sheet. The empty weight of an aircraft includes all operating equipment that has a fixed location and is actually installed in the aircraft. It includes the weight of the airframe, power plant, required equipment, optional or special equipment, fixed ballast, hydraulic fluid, and residual fuel and oil. Residual fuel and oil are the fluids that do not normally drain out because they're trapped in the fuel lines, oil lines, and tanks. Another term is empty weight center of gravity, and this is the point at which it balances when it is in an empty weight condition. Useful load is determined by subtracting the empty weight from the maximum allowable gross weight. And the useful load consists of fuel, any other fluids that are not part of the empty weight, passengers, baggage, the pilot, co-pilot, and crew members. As a technician, you must update the weight and balance anytime you make a change. Let's do a short review. The weight in pounds times the arm in inches equals the moment, which is in inch pounds. So if you install equipment, you are adding weight, that is a plus. If you remove equipment, you are removing weight, and that is a minus. As for the arm column, if you are installing or removing an item that is located forward of the datum, it is a negative arm. If you are installing or removing an item that is aft of the datum, it is a positive arm. Remember the rules for multiplication of signed numbers. When multiplying a negative by a positive, the result is always negative. When multiplying two like signs, the result is always positive. Now you add and subtract all the weights from the previous weight to get the new weight in pounds. Next, you add and subtract all the moments from the previous moment to get the new moment in inch pounds. Remember, a moment is a force. Once you have the weight and the moment, you can calculate the new center of gravity by dividing the moment by the weight. In this example, it gives us a CG of 24.03 inches aft of the datum line, since it is a positive arm. You need to update the aircraft weight and balance records with this information, and usually a form like the one shown here is used. As a technician that is going to approve the airplane for return to service and certify that it is airworthy, you need to verify that it is still within the maximum allowable weight and the CG is still in the allowable CG range. Keep in mind that for helicopters, there's oftentimes a lateral weight and balance record as well. The type certificate data sheet will also specify placards. Here is the statement about placards from the Bell Helicopter type certificate data sheet. Mechanics must ensure that all required placards are installed. On fixed wing aircraft, the fuel placards on the wing near the fuel filter are oftentimes painted over or not readable. Another placard that is sometimes missing are the placards for baggage compartments or shelves. Remember, we are still looking at conformity to type design. Now we will look at what equipment must be installed in an aircraft to maintain airworthiness. Remember, it must conform to type design. Equipment required by the type design cannot be removed. Check the equipment list. Although not an airworthiness element, certain types of operations require specific equipment. 91205 is where you find it. It defines VFR and IFR equipment requirements. Also, airspace can dictate equipment, although that's more of an operational rule. ADS-B equipment is now required, as well as a transponder. And generally, an ELT is also required by 91207. Check the full regulation. There are some exceptions. The equipment must not only be installed, but it must be operable. Reference Regulation 91.213D. The certification basis determines the equipment required to be installed. The type certificate data sheet for the aircraft will state something about equipment, and the original equipment list is provided by the manufacturer. Mechanics must keep the equipment list updated as they add and remove equipment. This is the certification statement from the type certificate data sheet for the Cessna 150 series that we saw before. Notice the certification basis list that also the airplane flight manual must be installed, and it also shows stall warning indicators. Here's an extract from CAR Part 3, which is the certification basis for this aircraft, and it says required basic equipment is to be found in paragraph 3.655. When we look at that paragraph, we can see the list of equipment that's required: airspeed indicator, altimeter, oil pressure indicator, tachometer, fuel pressure indicator, oil quantity indicator, and so on and so forth. Here's the required equipment statement from the Bell Helicopter Type Certificate data sheet. Note that it says everything required by the certification basis, and then it lists other items that must be installed in the helicopter. During an inspection, mechanics should verify that required equipment is installed, because the aircraft is not airworthy unless the required equipment is installed. In addition to the type certificate data sheet, the equipment list is a good place to look for required equipment. Here is the equipment list for a Cessna 172S. Notice R beside an item means it is required equipment. It must be installed. This airplane has the Garmin electronic PFD and MFD. Notice the standby instruments are listed. And it even lists a sensitive altimeter. So be careful you don't hurt that altimeter's feelings, because it is sensitive. Just a joke. But it also lists that some very specifics about this altimeter. And it even gives a part number. Here's an example of a kind of operation equipment list, or a KOEL. Notice that no VHF comms are required for day and night operation. This kind of follows along Part 91.205. Notice our chart also indicates a block for maintenance and documentation. Unless the aircraft is properly maintained in accordance with Part 91 and Part 43, it is not airworthy. An important part of this element is the documentation. Maintenance or preventative maintenance can be inspection, repair, or servicing, and these actions are intangible after the fact. Often, nobody will know if the aircraft was inspected or a repair action was accomplished after it's done. These actions must be recorded in the maintenance log. If it's not recorded, you have no proof it was accomplished. This is why the FAA takes falsification of records so seriously. The records are the only thing we have to determine what actions were done or not done. We owe it to the pilots flying the aircraft and the aviation maintenance technicians working on the aircraft after we've done our work to make good record entries. When's the last time you've read Block 6 of an airworthiness certificate? It has some excellent information that all aircraft owners and operators and mechanics should know. The certificate is only valid as long as the maintenance, preventative maintenance, and alterations are performed in accordance with parts 21, 43, and 91. And the aircraft is registered in the United States. Now we will look at the second element of airworthiness, condition for safe operation. Notice that the chart depicts wear and tear as influencing condition for safe operation. We all know that wear and tear, deterioration, does occur over time and use. Some might say that wear and tear is more intense for a flight school aircraft that is used more often and that is subject to hard landings, etc. So if you are working on these aircraft, keep that in mind. Older aircraft or aircraft with high utilization have more wear and tear. So what is safe or safety? Safety is defined as the condition of being safe from hurt or loss, keeping accident free. Let's keep this in mind as we see how to determine if something is in condition for safe operation. The question we must ask is, when does normal wear and deterioration become an unsafe condition? When normal wear and deterioration causes an aircraft part, structure, or system to no longer meet its type design, the aircraft is no longer in condition for safe operation. Here are some examples. Tire worn beyond limits, seatbelt frayed so as not to provide the design protection, or brake pads worn down so metal is on metal. We continue to ask the question on this slide. A good way to think of it is that old adage, it's an accident waiting to happen. It looks something like this. Notice he does have the rear wheel chocked, which tells me he's very safety oriented. Never mind that he's welding a gas tank. If a part is likely to fail and its failure will cause an accident, hurt, or loss, then that item is not in condition for safe operation. What about damage? In addition to wear and deterioration, damage can be included under the wear term, but the same principles apply. If the damage causes the part to no longer meet its type design, it is no longer airworthy. Always refer to the manufacturer's damage limits or contact the manufacturer if you are ever in doubt. Also, if damage causes a part to no longer be in condition for safe operation, it is no longer airworthy. Now let's look at some real life scenarios. These aircraft were observed in the San Antonio district. You notice dents along the leading edge of this wing. Is the airplane airworthy? This aircraft must be considered unairworthy until an airworthiness determination is made by a properly certificated person. And this inspection should then be entered into the logbook so that pilots flying the aircraft, once they see the dents, they'll be able to look in the logbook and see if the determination was made. Here is an example of a logbook entry that could be made for this damage inspection. And it states, inspected wing leading edge dent located on left wing at 60 inches inboard from the wingtip, found to be negligible in accordance with the Cessna 172 RG service manual, paragraph 17-12. Here are some seats from a Cirrus aircraft that were actually observed during a ramp inspection. Has this reached the point of an unsafe condition or nonconformance to type design? And does this pass an inspection? Part 43, Appendix D is our checklist for conducting inspections, and it states each person performing an annual or 100-hour inspection shall inspect seats and safety belts for poor condition and apparent defects. Obviously, this is a fail, and it is not airworthy. Here's an example of a tire that's worn beyond limits for safe operation. If you blow a tire on takeoff roll, you are likely to suffer hurt or loss. Also, it probably no longer meets its type design because tires are generally smooth and round. It's not in condition for safe operation. How long would you drive your car with a tire like this? Advisory Circular 20-97 covers tire wear, and the AMT Handbook Volume 2 on the FAA.gov website also has a good section on tire wear. You can also download the Goodyear Tire Care and Maintenance Manual at that website listed. Just click on the link that says Tire Care and Maintenance Manual. Here is a seat belt that was observed during a ramp inspection. It is not in condition for safe operation. Some may say this looks like normal wear and deterioration, but can you be sure this will withstand the G forces in a crash that are specified in the certification rule? There is the rule for a Part 23 aircraft, and this goes on to explain in lots of detail about the criteria that must be met. Upon further inspection, you see it's completely frayed through. It's definitely not in condition for safe operation, and it does not meet its type design. Now let's take a look at some factors that can affect airworthiness. We've completed our look at the two elements that are required for airworthiness: conformity to type design and in condition for safe operation. But here are some factors that can affect airworthiness. Type design changes. If it's an approved change, the aircraft remains airworthy. If it's an unapproved change, the aircraft is not airworthy. STC installed equipment is a approved change to type design, but it must be done properly. Keep in mind that STCs can impose additional maintenance requirements, the instructions for continued airworthiness. There can be new inspection requirements. So when you're doing an annual or 100-hour inspection, make sure you look at all the ICAs related to STC installed equipment or FAA 337 field approved equipment as well. There could be other inspections that need to be done in addition to what you saw in Appendix D. If equipment is installed that requires a field approval or an STC and none was obtained, the aircraft is no longer airworthy. So you should be looking for these documents when you perform an inspection. And if an inspection defined in an ICA is not accomplished, the aircraft is no longer airworthy. There's also pilot-induced factors. Hard landings can affect airworthiness. Airspeed exceedances can cause structural damage. RPM exceedances can cause engine damage, as well as over temp or over G'ing an aircraft can cause structural damage, or the over temp can cause engine damage. I observed seat belts hanging outside of a door once on takeoff when I was working for Dunkirk Avionics, and it really created a lot of damage to that aircraft. So, and that's a pretty common occurrence. It's so easy to forget on some aircraft and let that seat belt hang off outside the door. Wrong oil used during an oil change or a filter not installed properly is another pilot-induced factor. There's an actual incorrect oil filter was installed, and it caused that damage to that engine, and it caused the aircraft to crash. Exceeding the useful load or out of CG loading. This looks like the luggage my wife takes on a weekend excursion. Wrong or soft surface landings. How many times have we seen aircraft land on turf and tip over on their nose and create a prop strike? In addition, there are pilot-induced factors that influence airworthiness. Wrong part installed or part installed incorrectly. We're all human and we all make mistakes. There's many reasons why mistakes occur, but they do occur. Those last three, loose B nuts, engine controls improper, and cylinder torques incorrect, are the three leading causes of accidents after maintenance. Improper torque or a non-calibrated torque wrench or not used at all is also a factor that can affect airworthiness. Failure to follow procedures in the manual, inspection not accomplished properly, or a part or fastener not safety wired properly, or failure to accurately update the weight and balance. Here's an example of a mechanic-induced factor. It looks like a mechanic decided to attach the door handle with safety wire. This is not the approved attachment hardware called out in the aircraft maintenance manual, which, as we know, is part of the type design. What about condition for safe operation? Yes, it is probably safe to operate. The handle probably won't fall off, but is it airworthy? No, because it does not conform to the type design unless the manual shows safety wire here. Some might argue that this is a repair and it's equivalent to the original, which is stated by 4313. But remember, repairs have to return an article to its original or properly altered condition. And the aircraft maintenance manual and parts manual is part of the type design. This is definitely not airworthy. Here's a couple more examples. We have a cotter pin installed for a door pin on the left picture, and on the right is the incorrect seat stop hardware. If we allow whatever hardware a mechanic wants to use in various applications on the aircraft, where do we draw the line? Can instead of a cotter pin, can we use a finishing nail? We have to comply with the type design. Here's an example of a mechanic-induced factor. Let's say a technician installs a new item. Maybe it's an XM weather receiver. And he attaches the power wire to the terminal on the flap circuit breaker. Or another example where the technician attaches the power wire directly to the electrical bus with no circuit breaker. Why do both of these actions make the aircraft unairworthy? Well, it does not meet the type design and it is not in condition for safe operation, because there's the regulation from the certification basis. It says protective devices such as fuses or circuit breakers must be installed in all electrical circuits. Can't just connect it directly to the bus because there's no short circuit protection. And secondly, a protective device for a circuit essential to flight safety, such as the flaps, may not be used to protect any other circuit. So connecting the XM weather unit to the flap circuit breaker is a no-no. There's also environmental factors that affect airworthiness. Made a list here of some of them. Salt water can cause a lot of corrosion. Blowing sand can create windshield abrasion or abrasion of de-icing boots, for example. Snow loads can cause structural damage. Ice, the freeze and thaw cycle, can be very destructive. Heat, and especially UV, causes materials to break down. Wasps like to create nests in the pitot tubes. Rain and moisture in the pitot-static tubes. Remember, when you're doing an inspection, don't forget to drain the pitot-static lines. There can be moisture in there. And another example is volcanic ash, which can cause engine damage. Let's look at the life cycle of an aircraft. Aircraft comes factory new with its initial type design. This type design can be properly changed by an STC or a field approval, and the aircraft remains airworthy. The type design can be improperly changed, and the aircraft is no longer airworthy. Normal wear and tear occurs. Normal wear and tear eventually causes parts to no longer meet their design specifications, and the aircraft is no longer airworthy. Damage can happen. Maintenance occurs to repair defects, and airworthiness is restored. Inspections are done to identify and correct defects. Life-limited parts are replaced, hopefully before they fail. And then we saw pilot and mechanic-induced errors can affect the type design and airworthiness of the aircraft. We saw environmental factors can affect airworthiness. And eventually the aircraft ends up in the boneyard after parts are no longer available or lifetime limits are reached or economical repair is no longer possible. So let's summarize airworthiness. The aircraft must conform to its type design. Reference the type certificate data sheet, the manuals, the STCs, and the weight and balance and equipment list. No unapproved modifications. No unapproved parts. Required equipment must be installed, and we saw that it must be operational as well. Check the type certificate data sheet and the equipment list for required items. The aircraft must be in a condition for safe operation. Wear and deterioration is not excessive. Airworthiness directives are complied with, and damages are intolerance. Now, the final topic that we're going to discuss today are the performance rules for aircraft maintenance technicians. 43.13 are general performance rules. 43.15 are the inspection performance rules. And 43.16 are airworthiness limitations performance rules. The performance rules are the standard or quality that must be achieved during aircraft maintenance. Unlike a car mechanic, an aviation mechanic must follow these rules. When you return to service an aircraft after maintenance, you are only certifying the work you accomplished. 43.13 states that the person must use the methods, techniques, practices prescribed in the current manufacturer's maintenance manual, instructions for continued airworthiness prepared by the manufacturer, or other methods, techniques, and practices acceptable to the administrator. Except if you're doing work specified in the airworthiness limitations section of a manual or ICA, you shall perform the work in accordance with that section. And you also must follow the instructions contained within an AD. And remember, if an AD references a service bulletin, then that service bulletin becomes mandatory. 43.13, another thing you should keep in mind For aircraft that are operated under Part 121, 129, or a 135, 10 or more air carrier, then you shall use the methods, techniques, and practices prescribed in the maintenance manual of that air carrier. You become effectively part of their maintenance department. .4313 goes on to say that you shall use the tools, equipment, test apparatus necessary to assure the work is completed in accordance with accepted industry practices. Special test equipment or apparatus recommended by the manufacturer or an equivalent acceptable to the FAA must be used. And you shall do the work in such a manner and use materials of such quality that the condition is at least equal to its original or properly altered condition. A good example is a bolt that comes from the factory torqued to 20 foot-pounds, and you over torque it to 35 foot-pounds or under torque it to 15 foot-pounds. You have violated the performance rule. Remember, the word shall in a regulation is an enforceable standard. Always follow the manufacturer's procedures. .4315, the performance rule for inspections. Your inspection certification statement in the logbook says the entire aircraft is airworthy. Remember, this is different than an individual maintenance log entry where you're just saying the work you accomplished is airworthy. And it states, determine the aircraft and portions meets all applicable airworthiness requirements. For Part 125, 135, and aircraft under 91.409E, perform in accordance with the inspection program. For rotorcraft, it goes on to say you'll follow the maintenance manual and ICA and inspect the drive shafts, main rotor transmission gearbox. For an annual and 100-hour inspection, it states you shall use a checklist and it must include the scope and detail of Part 43, Appendix D. Additional rules, annual and 100-hour for a reciprocating engine aircraft. Before return to service, you shall run the engine and ensure it meets the manufacturer's recommendations for power output, magnetos, fuel and oil pressure, cylinder and oil temperature. For an annual or 100-hour or progressive on a turbine engine aircraft, before return to service, you shall run the engine and ensure it meets manufacturer's recommendations. 4316 covers airworthiness limitations, and it states you shall perform maintenance specified in the airworthiness limitations section of a maintenance manual or ICA in accordance with that section, or in accordance with the op specs of a Part 121 or 135 air carrier, or a 91.409E inspection program. I hope that today we have met our objective, and this has increased your knowledge of what defines airworthiness, and that you'll better understand how changes can affect airworthiness, that you'll be able to identify unairworthy conditions, and you'll be able to make a good determination as to whether an item is in condition for safe operation, and that you'll understand the factors that affect airworthiness. And especially that you'll know the performance rules that are required of you. You can find awards and wings info on the maintenance hangar or the pilot tabs on FAAsafety.gov. If you are not registered on FAAsafety.gov, I encourage you to go there, create an account. Whatever email you use to create the account is how we will identify you of upcoming seminars and webinars. It's very easy to do. And you can find courses with AMT credit. You can even find courses with IA renewal credit. Here's an example of the AMT award levels, the bronze. You get a bronze award if you take 12 hours, for example, or a silver if you get 40 hours of training. And you claim your award in January of every year. There will be a button that will appear and you can claim whatever award you have earned. There's some very good tutorials on the left side of our homepage, tutorials for individuals and employers, and also wings. If you have any questions about today's presentation, I encourage you to send me an email. There's my email address. And I want to thank you for attending today. You are vital members of our GA safety community. Until next time, this is Gary Mitchum signing off.